So I got another physics request, this time from Pearson. He wanted help with this question. An object weighing 15.0 kilograms is stationary on a hill with an incline of 23.0 degrees. A, what is the normal force? And B, what is the mu s, or coefficient of static friction of the object? So we should start by drawing a diagram. Let's just draw what the question says. 23 to says this it's not to scale, but this should be 23 degrees. 23.0 degrees. And then this is a right angle triangle. And just draw a circle for object. And let's just write down 15.0 kg. Okay. Now we have our diagram. So now we should start by drawing the forces on our object. So first of all, let me do that in a line. So there's gravity. Let's call that Fg. It's the weight of the object. And then we have normal force, which is perpendicular to the incline. Should be something like that. F N. And then you see the object is stationary. That word is important because that means all the forces can't have to cancel out. Right now, the forces are not equal. There's actually a force missing in this direction, and that is force of friction, or F. Let me zoom in a little. F. And yeah, this should be balanced now. Here, let me show another diagram to make it easier to see. This is, let's just say let's imagine this is flat, so Fn is straight up. Fn, then that means gravity would be off diagonal a little bit, or weight. So now, to make this easier to see, we need to split up weight into its components. This is F. So to do that, we just need to make a vertical component and a horizontal one into a right triangle. And because Fn and the vertical have to cancel out, then that means this side is equal to this side, so it's also Fn. It's the same thing, just in a different direction. And because these two have to cancel out, the two horizontal components, that means they're the same. So this is also F. Now let's draw that on our first diagram. It will look something like this. Triangle is to the side. variables. This is Fn. This is F. So now we need to solve for this. We can find Fg, which is the weight, easily, because we have gravity and we have the mass. But how would we find Fn from this? So we need to use this angle we have right here. It might not be obvious at first, but this angle right here is equal to this angle. So this is also 23 degrees. This is because this angle right here and this angle have to add up to 90 degrees, because all angles in triangle have to add up to 180, and there's already 90 degrees right here. But because Fn is perpendicular to the incline, that means that these two angles together right here have to add up to 90 as well. So 90, we don't even need to find this angle. We have, because this angle plus this angle equals 90, and this angle plus this angle also equals 90. So that means these two are the same angle. So yeah, now we can figure out the normal force from here. Let me never mind. Yeah, so first we can find the weight. So we have we need to use the formula F equals ma. Mass is 15 15.0 kg, and then acceleration is gravity, that's 9.81 meters per second squared. Now we just put that in our calculator. 15 times 9.81, that's 147.15. 87.15. We're not done with this value, so we shouldn't round it up just yet. But it should be 3 sig figs, and the unit is newtons. So now that we have Fn, let's write that down here, equals 147 newtons. Fg is, oh wait, no, my bad. Fg is 147 newtons. Then, yeah, this angle, this is 23.0 degrees, as I showed in this here. It's the same as this angle. So after this, we can use a trigonometric function. So we have hypotenuse, we have one angle, and we're looking for the adjacent of that angle. So the trigonometric function that has adjacent and hypotenuse is cosine. Cosine of 23 equals 23.0 degrees equals adjacent over hypotenuse, so Fn over 147.15 to 3 sig figs, and that's newtons. Now if we multiply both sides by 147, you have Fn equals, put that in your calculator, cosine 23 times 147.15. That gives us 135.45. We don't need to use this value again, so we can just round it up straight away to 3 sig figs. 135 newtons. Yeah, and that is our answer for question A. Now B, what is the mu s? Need to remember the formula. F of F equals mu s of Fn. So we don't have FF, we have Fn, and we don't have mu s. So we need to find FF first to solve this equation. So to find FF, we use pretty much the same thing we did in question A. So we're looking for the opposite of our angle, and we have the hypotenuse. So opposite and hypotenuse is a sine of 23.0 equals opposite over hypotenuse, so F over 147.15 newtons, 3 sig figs. Then put this in our calculator again. Sine 23 times 147.15. F equals 57.49. 57.49. Let's try not to round this very much. 57.4961. I usually like to go to 4 decimals to make sure it's precise, but 3 sig figs. And then after we have this, we can plug it in to the formula. So 57.4961 newtons, 3 sig figs, equals mu, yes, this is mu, of Fn. Fn was, oh, we were gonna use this. Okay, well, I don't think it'll change much if we have it rounded. 135 newtons. So yeah, now to isolate mu s, divide both sides by 135. So we have FF in our calculator, we can just divide that by 135. So mu s equals 0.426. And yeah, that should answer our question. Okay, yeah. So thank you, Pearson, for the question, and let me know if you want to see another video. Bye.